So the electronegativity is just the tendency to attract shared pair of electron more toward itself, and the element which is smaller in size is more electronegative, and the element which is bigger in size is electropositive. Now you all are familiar that which element is going to be bigger in a group and which element is going to be smallest in the group. So likewise the electronegative character and the electropositive character varies. So that means if we talk about extreme left, we have the group which is maximum bigger in size, so they are electropositive, and we have the 17 group which is too small in size, so they are all going to be electronegative, and the element which is at the top on the right side are going to be more electronegative if we compare it with the rest members. And now I want to discuss few questions with you. So the first question being like actually they are you can say beyond your syllabus, but I just want you to actually explore your ideas that what kind of exception we get to see, we are seeing in the periodic table, and what might be the reason behind. So out of fluorine and chlorine, we have 17 group: fluorine, chlorine, bromine and iodine. So out of fluorine and chlorine, which is smallest in size? Obviously it is going to be fluorine, right? And if we talk about the electron affinity, that means if I add an electron to fluorine and if I add an electron simultaneously to chlorine, in which case I am going to get maximum amount of energy? It is for the case of, you must be thinking it is for the fluorine, that is it is too small in size, but you will get to know that it is for the chlorine. Actually it has the less electron affinity as compared to chlorine because it is too small in size. So whenever an electron is approach to it, it gets added, it suffers a lot of you can say the repulsions. So that means its electron affinity unexpectedly is low as compared to the chlorine because it is slightly bigger in size and the repulsions between the electrons are not too high. So these are the properties which I have clubbed for you. I am just recalling those properties so that you should know that we have done it and you are easy to remember them. The first is the atomic radii, the size, the distance between from the nucleus to the outermost shell. A long group, you know that it increase, and a long period it decrease. The second property we took was the ionization energy, the energy which is required to remove an electron from the outermost shell of an atom, and whenever the electron is added or electron is removed, it happens only in the outermost shell. And one more condition you have to keep in mind, that whenever the electron is added or electron is removed, it all happens when an atom is in gaseous state. So before you add an electron or you are removing an electron, you need to convert the solid metal into the gaseous form. That means we have to do the sublimation in that case, because everything at electronic level, whenever the electron is added or it is removed, it has to be done at gaseous state. So the definition clearly states the amount of energy released or you can say the amount of energy required to remove an electron from outermost shell of an atom when it is in gaseous state. Similarly, for electron affinity, it is the amount of energy released when electron is added to the outermost shell of an atom when it is in gaseous state. So just keep in mind that gaseous state word is very important. It should be there in your definition. And the third property we did was the reactivity. Reactivity means tendency to lose or gain electrons, right? And tendency also depend upon the nuclear charge, the force of attraction and the size. You know that the ionization energy and electron, all these properties are actually interrelated, right? And the next property was nature of oxides. That means it is going to a basic oxide or acidic oxide or neutral oxide or an amphoteric oxide, right? And the next property was metallic and non-metallic character. It is actually related to the chemical reactivity, you know that now. Next property we did was electronegativity, and it plays an important role because it makes the covalent bond. Otherwise the covalent bond has no charge, but it makes the covalent molecule as charged molecule, and whenever the covalent molecule is charged molecule, it is called to be as polar covalent bond. Otherwise the covalent molecules do not have any such kind of charge. It is called as the non-polar ones, but it is due to the electronic difference in the electronegativity that the bond becomes polar or non-polar. So this polarity phenomena is very important. You will be learning in the higher class that how it happens. So you are all familiar with these properties now, and I think that you will be keeping in mind and you will be carefully noticing it, and just keep in mind whenever you are doing these properties now, you have to just concentrate on the position. If you will be thorough with the position, the answer is easily going to strike you. And moreover, when you are attempting the answer, just don't go at the last point. Start from the sequence that it is small, so that means nuclear charge is this, so that means the energy is going to be this, that means this. So just relate the properties. The time you will relate them, it will not create a confusion in your mind, and you can easily attempt the answer in a very well manner.